It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other, where you put your knowledge to test
and battle it out with a test
to bring out the best in you. Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest. Fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Welcome to Unacademy and welcome to Unacademy Semester Exams. Today, as a part of Control Systems Quick Revision for Semester Exams Chapter 5, we are dealing with Lecture 9, and I'll tell you what we are going to discuss today. Before that, let me tell you about myself. I'm sravan Kumar with 7+ years of teaching experience and mentored more than 5K students and also cracked GATE. And Unacademy, let's crack GATE and ESE with India's largest learning platform, Unacademy. You can also install Unacademy Learning app from Google Play Store and you can get the following benefits: daily live classes, structured courses, live test and quizzes, and unlimited access. You can also get the personal coach, study tracker, mains question and answer practice, and all the benefits in Iconic subscription. And if you're opting for Plus subscription, you'll get daily live classes, structured courses, live test and quizzes, and unlimited access as well. And you can learn from the top educators of the Unacademy, as you can see. Also, you have for GATE and ESE batches and year-long courses for all the branches and all the specializations. And if you are opting for Iconic, you have all the benefits of Plus along with some special benefits like personal coach, personalized test analysis. Yashodhar, good evening. Preparatory study material, etc. And if you want to opt for Plus subscription, you can use my code to get the maximum discount on this price. And if you are opting for Iconic, which is one of the suggestible one, for 24 months, you can use my code YSK10 to get the maximum discount for a limited period of time. So the topic for today is Control Systems, Chapter 5. I have segregated this Chapter 5 into two parts. As a part of Part A, in the previous session, we have discussed a few things, and in Part B, we'll discuss the rest of the things. In Part A, we have discussed ZIR, ZSR, that is nothing but the solution of the state equation, and I also told you about state model and state diagram. Then we have discussed state transition matrix. In this, we will discuss what is diagonalization. And in part B, we'll also discuss controllability and observability. and the discrete time systems. We'll just try to solve some questions based on the questions. Good evening, Parimala. Based on the questions, we'll try to solve some, get some answers to them. First, let me discuss about this diagonalization. This diagonalization is actually is converting a given matrix A into a diagonal matrix. That is, let's say if you have a 3 by 3 matrix, you have only the diagonal elements x, y and the z, and upper and lower triangular, lower half diagonal elements to be 0. So what are these eigenvalues is the diagonal elements are nothing but the eigenvalues. Diagonal elements of a diagonal matrix. Diagonal elements of a diagonal matrix are nothing but the diagonal elements are nothing but the eigenvalues. And what does this eigenvalues indicate? Eigenvalues are nothing but the poles of the transfer function. Poles of the transfer function, by which you can comment on the stability of a system. By which you can comment on the stability of a system, right? So this is nothing but the diagonalization. So there are also some advantages of this diagonalization, that is, you can find the controllability, observability, and you can also easily find the eigenvalues of the system, and so on. So what, we'll take up one example and I'll tell you what is the procedure to do that. So I'll just draw a flowchart sort of thing to let you understand how we diagonalize. You'll be given a matrix. A is a matrix, and from that what you have to do is you'll have to find lambda I minus A is equal to 0. Here you'll get what is called as eigen values. Here you'll get the values of lambda 1, lambda 2, if it is 3 by 3, lambda 3, right? And from here you can find the values of, from this lambda 1, lambda 2, lambda 3, you'll get eigenvalues, and using lambda 1, lambda 2, lambda 3, you can get three matrices. You'll substitute these values in, substitute lambda 1, lambda 2, lambda 3 in mod lambda I minus A into x is equal to 0. So from that you will get a modal matrix M1, M2 and M3. Three matrices you will get it, because you have three different values. You will substitute these three different values. From here what you do is you will write a modal matrix M. M is equal to, here you will write M1 as one column, M2 as the other column, and M3 as the third column. M3 as the third column. So after this writing M, we'll have to find M inverse. So in order to find this M inverse, what we do is we will first find minus, then cofactors, then transpose that. Then what you get is you'll get adjoint. This is called as the adjoint of A. From this adjoint of A, then you need to find after this, and parallelly you can also find here, while finding minus you can find the modulus of M. So once you do this modulus, you can combine. Maybe you'll not be able to see this. I'll just move this down. Yeah, somebody was asking. So once you do these two, you can combine them and write M inverse. M inverse is nothing but adjoint of, this is adjoint of M. This is adjoint of M by det M. This is adjoint of M by det M. So this is M inverse. So once you know the value of M inverse, for diagonalization, write M inverse A into M. Right? M inverse A into M. Let's take one example. I'll first take an example that is a previous example. One example I'll just take down, and let us say you are asked to diagonalize. I'll take a 2 by 2 matrix, then we'll take up some 3 by 3 matrix as well. Let me take one. From your question papers, I'm just trying to pick one. Yeah, let us say you have matrix A is equal to 0, 1, minus 1, minus 2. Let us say you are having this. Let's say this is the matrix and the question asked is diagonalize A. So what do you have to do? First, this is a simple matrix. What is the solution that you have? Diagonalization D is equal to M inverse A into M. Have to get these values. So let's take one example so that you'll get the values. So diagonalize A, you'll have to do this D is equal to M inverse A M. So for that, first you need to find the modal matrix. What is the modal matrix? As I told you, modal matrix is equal to M1, M2 and M3. Modal matrix is equal to M1, M2 and M3. Modal matrix is equal to M1, M2 and M3. Let me take one question. So you'll have to find modal matrix M1, M2 and M3. So for finding M1, M2, M3, what do you need? How do you find this? By substituting lambda 1, lambda 2, lambda 3. What are lambda 1, lambda 2, lambda 3? These are the three state variables. These are the three eigenvalues. Lambda 1, lambda 2, lambda 3 are the eigenvalues. So for the first given question, let me take one question which gets some roots, because sometimes if you do not take a question properly, what happens is you will not be able to get the eigenvalues, real eigenvalues, rather you will get an imaginary eigenvalues. So as a result, you will not be able to solve that. So we'll have to take one good example. For that, I'm just taking one example here. Right. So let's take, just change this question, which many of you have solved this. So I'm taking 0, 1, minus 2 and minus 3. So for this, what I'll do is, first we'll have to write lambda I minus A mod is equal to 0. So first find lambda I minus A. What is lambda I? Lambda 0, 0, lambda. How did I write this as 2 by 2 matrix? Because here the given question also has a 2 by 2 matrix. So I am writing this also lambda I. This is a matrix and this is also a matrix. Minus, I'll have to write the A matrix 0, 1, minus 2, minus 3. We'll also solve 3 by 3 matrix, do not worry. So lambda I minus A. So once you do this, you'll get lambda minus 0, lambda 0 minus 1, 0 minus 1, minus 1, 0 minus of minus 2 plus 2, lambda minus of, this is lambda plus 3. So we'll have to find det of this. So write determinant of lambda I minus A is equal to 0. So implies det of, what is that value? Lambda minus 1 to lambda plus 3 is equal to 0. So how do you find? Just AD minus BC, lambda into lambda plus 3 minus minus 1 into 2 is equal to 0. You will get lambda square plus 3 lambda plus 2 is equal to 0. If you find these values, if you find the roots of this, you get lambda is equal to lambda 1 is equal to minus 1 and lambda 2 is equal to minus 2, right? You can write this as lambda square plus 2 lambda plus 2 is equal to 0. So you got two values, and what are these values called as? These values are called as eigen values. These are the eigen values. Now at lambda 1 is equal to minus 1 and lambda 2 is equal to minus 2, let us try to find eigenvectors. Let's try to find eigenvectors. For that, what do you need to take? You need to write lambda I minus A into x is equal to 0. So what is lambda I? Lambda 0, 0. You already know lambda I, right? We have already written lambda I. So lambda minus 1, lambda minus 1 to lambda plus 3 into You should write it as x1 x2 is equal to 0. So what is this? Just multiply. In order to multiply this, first you need to substitute this lambda value. So lambda 1 is equal to -1. So -1 -1 2 -1 plus this is 2 into x1 x2 is equal to 0. So let me substitute this next time. First I'll write it down as, I'll just write r2 tends to r2 minus 2r1. So what do you get? That -1 -1 0 0 into x1 x2 is equal to 0. So can I write this as x1 minus x2 is equal to 0, or x2 is equal to minus x1? So what we'll do is we'll write let k is equal to, or let x1 is equal to k. So what do you get? x2 is equal to minus k. So what is the first matrix? M. M is equal to k minus k, or k if you take common it is 1 minus 1. So next we'll substitute lambda is equal to -2. Where do you have to substitute? Lambda I minus a into x is equal to 0. What is lambda I? It is lambda 1, 2, lambda plus 3 minus into x1, x2. Column matrix is equal to 0. Now lambda value is -2, 1, 2, 1 into x1, x2 is equal to 0. Now let's look at the matrix. Yeah, it's -1, 1 minus 1. Yeah, this is -1. So this will also be -1. So once you multiply this, you'll get, what I'll do is I'll write r1 tends to r1 plus r2, then you get 0 0 2 1 into x1 x2 is equal to 0. So from this, can we write it as 2x1 plus x2 is equal to 0? Yes or no? Yes, you can write it as 2x1 plus x2. Good evening, Yashodhar, Parimala and Shivakumar. So I'll write let x2 is equal to k. What is x1 is equal to? Right. So x2 is equal to k, or let's write x1 is equal to k. That's better. So let's write let x1 is equal to k. What is x2 is equal to? Minus 2x1, that is minus 2k. Yes or no? This is minus 2k. From this, can I write it as model matrix 2 is equal to x1 x2 is equal to k minus 2k is equal to k into 1 minus 2. So you got two model matrices. M1 is equal to, what is M1 that we got? Yes, let's see. So this is M1, you can see 1 minus 1, M1, M2. You should write it as column, that is 1 minus 1 and 1 minus 2. So you got this model matrix M. M is equal to, this is M. So when you know M as 1 minus 1, 1 minus 2, you should find M inverse. We already know that if M is equal to A, B, C, D, then M inverse will be 1 by AD minus BC, D minus minus 1, right? This is minus 2, it is a 3 by 3 matrix, that is 0. So from here you will have to find eigen values. You'll have to find eigen values. Okay, once you get those eigen values, try to find eigen vectors. By substituting these values of eigen values, you'll get 3 lambda 1 lambda 2 lambda 3. Then you need to write eigenvectors m1, m2, m3. Find modal matrix that I have told you in the previous problem. You write it as m1, m2, m3 here. Then you can find D is equal to m inverse A m, because this is a 3 by 3 matrix and we'll have to go with the other topics also. I'm just concluding it here. You can just solve this. The only difficulty is you need to just find this lambda I minus A. So you should take first lambda into the product of these two minus the product of these two, then minus 1 into the product of these two minus the product of these two, like 0 into, anyway if you just product these two and try to multiply by 0, you'll get a 0. That's how you got lambda into lambda of lambda into lambda plus 6 plus 14. That's how you get lambda square plus 6 lambda, lambda cube plus 6 lambda square plus 14 lambda. Minus of minus, this is already a minus, you have a minus here, so you'll get a plus here, and lambda square plus 6 lambda, right? So if you just write lambda cube plus 6 lambda square plus 14 lambda plus lambda square plus 6 lambda is equal to 0, and 6 lambda square plus lambda square 7 lambda square 16, 6 lambda plus 14 lambda 20 lambda. From that one value you can say lambda is 0, right? So you can just substitute this and you'll get these values. Now let's move on and see about controllability and observability. By Kalman's test, I'll only discuss here Kalman's test, right? Kalman's test. So controllability and observability by Kalman's test. A system is said to be controllable if its state can be changed, right? If you can change its state from one initial state to any other state, then you can say that the system is controllable. And a system is said to be observable. A system is said to be observable if all its parameters are measurable. And in order to calculate the observability and controllability of any given system, Kalman has given composite matrices QC and Q naught. QC is composite matrix to determine controllability B, A square B and so on, A for n minus 1 B, and Q naught is composite matrix for observability C transpose, A transpose, C transpose, A transpose square, C transpose and so on, A transpose for n minus 1 C transpose. So you need these in order to comment on the stability of a system. And we say that the system is stable if modulus of Q is not equal to 0 QC or modulus of Q naught is not equal to 0. Okay, so this is one question that you can see. Now, in order to find whether the given system is controllable or observable or not, we'll take up one question. Question is, see, there are some questions. First, I'll write all the questions. It is find from one of your university question papers, controllability and observability of system described by described by x dash is equal to a into x plus p into u and y is equal to c into x. See, this is one of the important topics I can say, and I want everyone to listen to these sessions and also inform your friends to join the sessions. It is very important. Now, also given a is equal to minus 2 1 1 minus 2 and b is equal to 1 and 1, c is equal to 0 and 1. So please do inform your friends, ask your friends to join the session and get benefited. Controllability, observability, this is one of the frequently asked questions and I want every student to learn this, right? Controllability, observability. Are you able to listen to my session or not? Is there any error that you are facing? So everyone please mark your presence or just tell me if you are able to listen to me. I found some students saying there is some error. Just drop a message in live chat box so that I'll know if you are able to hear me properly. Yes, everyone. I'm going to solve this question. We'll wait for 1 or 2 minutes and let's see how the students will respond. I want someone to respond. I want someone to respond and we'll try to solve this. We'll try to find the controllability, observability of system described by the given equations, given matrices. Yes, sir. Nikita Reddy, yes, sir. Yes, Yashodhar, yes, sir. All right. So I want everyone to mark your presence and we'll see. Okay, so what is that he is asking us to find? He asked us to find the controllability and observability, but did he mention any method? No, he did not mention. So what I do is I'll go by Kalman's test. Kalman's test for first we'll go with controllability. We'll go with controllability. What is controllability? Composite matrix QC is equal to B, AB, A square B and so on A power n minus 1 B. So in order to Harita, yes sir, your voice is clear. Thank you Harita. Good evening Soumya. Welcome to Unacademy. Good evening Harita. Good evening Nikita. Now inform your friends that we are going to solve some problems on controllability, observability and also on discrete time systems. Okay, so Kalman's test. In Kalman's test, what are the matrices that we need? A, B, A, B. Only A and B. And how many number of columns must exist in this? That depends upon the given question. So what is the size of this matrix A? This is 2 by 2. So this must also be 1 by 2. So where n is indicates the size of, let me tell you, the size of A is n by n. What is n then? N is number of state variables. N is number of state variables. So can we say that QC is equal to, see we have written B, AB, A square B and so on a power n minus 1 b. Here n is also number of state variables. So what is n? N is 2 here. If you can see, this is 2. So this is 2 by 2. If you write 2 by 2, 2 minus 1 is 1. So a power must be 1. So you can only take these two values. A power must be only 1. So you can neglect these values. So can I write QC is equal to B and AB? So do you know B already? Yes, B is already given. Now what is that I need to know? I need to find A into B. A into B. So multiply A with B. Multiply A. There were so many absentees to the previous sessions also. There are so many students who did not listen to these lectures. So I want you to inform your friends and ask them to join these sessions. Now A into B. This is A and let's say this is B. What is A matrix? Minus 2 1 and 1 minus 2. What is B matrix? 1 and 1. If you multiply this, what is the size of this matrix? 2 by 2. What is the size of this matrix? 2 by 1. What is the resultant size? You should get it as 2 by 1. You should get it as 2 by 1. So this is 2 by 1 matrix. 2 by 1 matrix you should get. So minus 2 into 1. So you should multiply this with this. Then add, then plus this into this. So that's what you have to do. So row with the column. Okay. So let's do that. Minus 2 into 1 minus 2 plus 1 into 1 1. Next, this is first element. This is 2 by 1 matrix, right? So next element 1 into 1 1 minus 2 into 1 minus 2. So what is that you get here? Minus 2 plus 1 minus 1 1 minus 2 minus 1. Yes or no? So what is QC is equal to now? QC is equal to BAB. That is, what is B? B is 1 1 and 1 BB. This matrix is 1 1 and AB is minus 1 minus 1. You can see minus 1 minus 1. That's right. Now, if you want to find det of QC, what is det of QC? 1 minus 1, 1 minus 1, determinant. So I'll write 1 into minus 1 minus of minus 1 into 1. What do you get? Minus 1 plus 1 is 0. Therefore, rank of QC is not equal to n or number of state variables. This indicates that therefore given system is not completely controllable. This is what you have to write. So this is about controllability. Let's check observability. Let's check observability. What is observability? Now the QC matrix for observability or Q naught matrix is C transpose, A transpose, C transpose, A transpose square C transpose and so on, A transpose power n minus 1 C transpose. We already know that n is equal to 2. N is what? 2. Therefore, what is QC matrix? Q naught matrix is equal to C transpose. If you place here n is equal to 2 minus 1, it is 1. So A transpose power must be 1. So you only have this and till this point you need to write A transpose C transpose and you need to find its determinant. Now first find what is C. C is already given as, what is the C matrix that is given? Check out. C matrix is already given 0 and 1. See, this is 0 and 1. And you need 0 and 1. we need C transpose. So write C transpose is equal to, it will become a column. So because its size is 1 by 2, 1 row 2 columns, it is 2 by 1 matrix. Next, you need A transpose. What is A first? It is minus 2 1 1 minus 2, I guess. Minus 2 1 1 minus 2. What is A transpose? So it is same size matrix, but the only difference would be this is minus 2 1 1 minus 2, the same. What is that? You are getting the same thing. Now first one is C transpose, first column. Second is A transpose into C transpose. So let's try to calculate that. So A transpose into C transpose is equal to minus 2 1 1 minus 2. This is A transpose, right? Minus 2 1 and 1 minus 2, and C transpose was 0 and 1. Now what is the size of this matrix? It is 2 by 2. Size of this is 2 by 1. So the resultant matrix size is also 2 by 1. Now multiply this minus 2 with 0, that is 0, plus 1 into 1 is 1, and 1 into 0 is 0, minus 2 into 1 is minus 2. So what is that matrix? You get 1 minus 2. This value is A transpose C transpose. So let's say Q naught. What was Q naught? We know C transpose, A transpose, C transpose. Right? You need to write them. What is C transpose? You know 0 and 1. What was A transpose, C transpose? 1 minus 2. Now calculate controllable observability. That is mod of this value 0, 1, 1 minus 2. What is that? 0 into minus 2 minus of 1 into 1. Minus 1 into 1. So this is minus 1. Is it equal to 0? No. Therefore, rank of Q naught is equal to n. Therefore, given system is completely observable. You can say that, right? So this is the answer. If you still have any doubts, you can check out once. I'll just give you one more time. See, this is from here. Just check it out. So this was the question. You have taken controllability. If somebody is taking some notes, you can also. It's better if you write always a running notes. So you got, it's not completely controllable, and we went for observability check. What is this observability check? Kalman's test for observability. Kalman's test for observability. So we got it as given system is completely observable. So let's try to, I'll just give you one more question and I want you to solve it. You can check, likewise you can also check, I don't find much questions, but let me also check some other. Okay, so this was the procedure, as you can see. So finally we can say for controllability and observability, for controllability and observability by Kalman's test, you just need to use this. You not C transpose A transpose C transpose A transpose square C transpose and so on A transpose for n minus 1 C transpose. For controllability, B A B A square B and so on A power n minus 1 B, and you need to check that both these mod are equal to n if for them to be controllable and observable. If not, if they are not equal, they are not controllable and not observable. Right? So now let's move on to the next topic. Discrete time system. Okay, now let's move on to this discrete time system. Discrete time systems are represented by x of n, and they are governed by difference equation, and they are analyzed by using z transforms. So the z transform of x of n is x of z. So this is discrete time system. And the second point, they are governed by, as you know, difference equations. You have some difference equations and you need to apply z transform and inverse z transforms either to find x of n or x of z. Right? Now the state model of a discrete time system. The state model of a discrete time system is given by x of k plus 1 is equal to a into x of k plus b into u of k, and y of k is equal to c into x of k plus d into u of k. So this is the state model of discrete time systems. State model of discrete time systems. Now you can write the solution of discrete time systems as x of k plus 1 is equal to a into x of k plus b into u of k. Apply z transform. If you apply z transform, this is z into x of z is equal to a into x of z. Because this is a solution, you also need to consider the initial conditions. So a into x of z plus b into u of z. So the transformation of x of k plus 1 is z into x of z minus z into x of 0. X of k, z transform is x of z. U of k, z transform is u of z. Right? So you just need to take x of z terms on one side. So I'll write z into x of z minus a into x of z is equal to z into x of 0 plus b into u of z. Right? So we write zi minus a into x of z is equal to z into x of 0 plus b into u of z. Finally, you can write x of z is equal to taking zi minus a to the right hand side into z into x of 0 plus zi minus a inverse into b into u of z. Right? So if you want to apply find x of k again, so it is inverse z transform, so will give you z inverse of the total term, that is zi minus a inverse into z into x of 0 plus zi minus a inverse into b into u of z. So this is the solution of the discrete time systems. And let's say you are asked a question. Let's try to find some question and answers. So find the state model for given transfer function, and the transfer function is given like this: y of z is equal to, y of z by u of z is equal to 3z plus 1 by z square plus 2z plus 7. Now you are asked to find the state model for the given transfer function, and this state model from transfer function can be done by using two techniques. One is signal flow graph, technique, and the second one is partial fractions partial fraction method. One is signal flow graph method, the other one is partial fractions method. Right? So let's try to do this signal flow graph method first. So first we'll see signal flow graph method. Right? So signal flow graph method. So because you have y of z by u of z is equal to, what is that, 3z plus 1 by z square plus 2z, z square plus 2z plus 7. We can take the highest power in the denominator common and take it to the numerator. 3z by z square plus 1 by z square by 1 minus of, if we just take minus common in the 1 plus 2z by z square plus 7 by z square. I have taken the z square common and took it to the numerator. So y of z by u of z is equal to, you can write 3 by z plus 1 by z square by 1 minus of minus 2 z power minus 1 minus 7 z power minus 2. So you can just take this to the next slide and draw the signal flow graph. So let's try to take the signal flow graph. So I'll just take some nodes randomly. And what is this? Minus 2 z power minus 1 is a loop. The highest power in this is z power minus 2. So you need to have 2 z power minus 2, that is delay. So that is 1 z power minus 1 and the one is minus z power minus 1. So you have 2 z power minus 1 delays because it is z power minus 2 highest. So we can say that this is a loop and this is another loop. So you have two loops. So loop is -2 into z power -1. Then another loop 2 is 7 into -7 into z power -2. So I can draw a loop here. This is z power -1 already. So from here I'll just take a loop and mark it as -2. So in this loop, if you see, if you observe this loop, this is z power -1 and this is -2. So it will be, you just take as a single line, it is z power -1 into 2 -2. So this is same as this. That's how you can do. Next, the second one is -7 into z power -2. So this is already z power -1, this is z power -1. So I can just take a loop here from these two. Now this is z power -7 into, this is -7 into minus, you can take loop like this. This is z power -1, this is z power -1 and this is -7. So what is the value you get? Z power -2 into -7, that is -7 into z power -2, right? So after drawing this, it's not yet complete. We have only drawn the denominator part. We also need to draw the numerator. We have 3 by z, or we can write it as 3 into z power -1. This has z power -2. Yes. So is plus 3 into z power -1 plus z power -2. So 3 into z power -1. If I take this as 1 and this also has a 1 value, 1 into z power -1. This is the nodes. Let's mark these nodes as 1, 2, 3, 4 and 5. So from 1 to 2, if you travel, it is 1. 2 to 3, it is 1. From here, you can directly travel to 5 and say that this value is 3. So this will be 1. This will be z power -1. And if you multiply it with 3, so 3 into z power -1. So what should I do? I should draw a forward path. So I should draw a forward path. And this is 3. This is 3. So there is another one. You can see z power -2, and that means 1 into z power -2. So if I just take 1, 2, 3, 4, 5 nodes, that is very simple, right? 1, 2, 3, 4, 5. Here you have a 1, here you have z power -1, here you have z power -2, here you have a 1. What is the gain product of this? Z power this is z power -1 into z power -1 will give you z power -2. So this value directly, yes. Now after you get this, now what you have to do is just carefully observe here. After you get this, let's take this, the rightmost you should consider. So what first what is the, you are asked to find what state model, right? Let's see, the question is state model. And what is the highest power in the denominator? It is 2. So the state model will be something like this: x1 of k plus 1, x2 of k plus 1. This is 2. You'll have two elements into A matrix into x1 of k, x2 of k, right? So this is how you write it. So you have two state variables, you can see discrete state variables. So for this also you need two state variables. For the rightmost integrator in continuous time, we take the output as the first state variable. Similarly, for the rightmost delay, take the output as the first variable x1 of k. Now if this is x1 of k, the input of this will be x1 of k plus 1. x1 of k plus 1, z power -1 will give you x1 of k. And I'll call this as x2 of k. I'll call this x1 of k plus 1 as x2 of k. If this is x2 of k, what is this value? This is x2 of k plus 1. And I cannot call this as x3 because I have only two state variables. Now write the expressions for x1 of k and x2 of k. So what is x1 of k plus 1, it is x2 of k. And what is x2 of k plus 1? You should know that this is input u, this is output y, because y by z is y by u is given, right? So what is x2 of k plus 1? This is x2 of k plus 1 node, and there are three arrows, 1, 2 and 3. And this one, the first one is coming from u, so it is 1 into u, and second one is coming from minus 2 from x2 of k, so that is minus 2 x2 of k, and minus 7, third one, this third one is coming from minus 7 x1 of k, minus 7 x1 of k. So finally you can say that you can write this in terms of matrix. We'll take this to the next slide, and I'll also write y, then we'll take this to the next slide. Let's write y. So what is y? There is an arrow coming to this y from two places. One is from x1 of k and the other one is from x2. You should write only in terms of x1 and x2. So can I write y of k is equal to 1 into, this is 1, right? This is 1. So this is 1. So 1 into x1 of k minus 3 into x2 of k. This is plus, not minus, it is plus of. So finally I can take this and write a state model in the next page. So these are the state equations. To these state equations you can write x1 of k plus 1, x2 of k plus 1 as a matrix is equal to matrix A into x1 of k and x2 of k plus matrix B into u of k. What is the size of this matrix? 2 by 1. So this is also, so to get the resultant of 2 by 1 you need to have this matrix as 2 by 2, and because this is 1 by 1, this must also be 2 by 1 to get the resultant as 2 by 1. Now in x1 of k, do you have x1 of k plus 1? Do you have x1 of k? No. So first value will be 0. Do you have x2 of k? Yes. Its coefficient is 1. Similarly in x2 of k, do you have the value of x1? Yes. Minus 7. Do you have x2? Yes. Minus 2. And in x1 of k plus 1, do you have u? No. 0. This is 2 by 1, right? And do you have u in x2 of k plus 1? Yes. What is the coefficient? 1. So this is. Similarly, I can write y of k plus 1, y of k, sorry, it's not y of k plus 1, it's y of k into c into x1 of k and x2 of k plus 0. You do not have u in this. So I can neglect that also. So in y of k, do you have x1 of k? Yes. What is the value? And what is the size of this? This is 2 by 1. What is the size of this? This is 1 by 1. What should be the size of this? This should be 1 by 2. That is 1 row, 2 columns. 1 row and 2 columns. This is 1 and this is 3. So this represents the state model. This represents the state model. This is the state model by signal flow graph method. Hope you have understood this. Everyone. Yes, just let me know by some messages in the chat box. You can also do it by using partial fractions method. This is what we have done. Just check this method. Yeah, from here. Hope you have understood this. So shall we move on to the next problem? So I'm gonna write one problem and I want you to tell me. Yeah, this is the question. Let's take one question that is given. I'll just directly write the answers, but you have to solve it. A discrete time system is described by, you can also make a note of it, the difference equation. Difference equation. That is y of k plus 2 is equal to, sorry, y of k plus 2 plus phi y of k plus 1 plus 6 y of k is equal to u of k, and y of 0 is given as y of 1 is equal to, it is given as y of 1 is, and t is equal to 1 second. And what is asked is, first one is determine a state model in canonical form. This is one question from Nagurkari. You can just check it out. Question B is find state transition matrix. Find state transition matrix. And there is another question that is also asked. Third one, for input u of k, for input u of k is equal to 1, k greater than or equal to 1. Find output y of k. Find output y of k. So this is the question. So how do you find the solution? First, before this, I'll just tell you one more thing. A very simple thing. Let's say you have a difference equation like this. You have a difference equation. If discrete time systems are governed by difference equations, right? Let's say you have y of k plus 3 plus 0.4 into y of k plus 2 minus 2 into y of k plus 1 is equal to u of k. What do you write for this? If you apply z transform, you can write z cube. In order to find transfer function, z cube into, because this is third delay, 3 times delay, that is y of z plus 0.4 into z square into y of z, because this is second delay, 2 times delay, z square minus 2 into, this is 1 time z delay, so z into y of z is equal to u of z. So this is what is the z transform of this difference equation. If you want to find y of z by u of z, what do you take? It is 1 by, just take this, z cube plus 0.4 z square minus 2z, z cube plus 0.4 z square minus 2z. Just take common y of z in this. Similarly, in this given question also, this is the difference equation. What is this? This is the difference equation given. Let's write this difference equation, or else I'll just take, yeah, let's write this difference equation. What is the difference equation? I'll just write it down. Y of k plus 2 is equal to, sorry, y of k plus 2 plus 5 y of k plus 1 plus 6 y of k is equal to u of k. Now, what is the first question that is asked? Determine the state model. So in order to find the state model, in order to find state model, first thing that you need to know is, remember, you need a transfer function. You need a transfer function, right? To get the transfer function, you need to apply z transform. So apply z transform to equation. Let's call this as 1. Apply z transforms to 1. What happens? What do you get? Y of k plus 2. What is this? This is z square into y of z plus 5 into y of k plus 1, z into y of z plus 6 into y of z is equal to u of z. Now take common y of z, you get z square plus 5z plus 6 into y of z is equal to u of z. What is the transfer function? Input is u, so output is y. You know that. So output y of z by u of z is equal to, from this, y of z by u of z is equal to 1 by z square plus 5z plus 6. See, z square plus 5z plus 6. Yes, yes. And we are asked to find what is that state model in canonical form. So you can use partial fractions method. So use partial fractions partial fractions partial fractions method. So what can you write? Y of z, I'll just find first partial fractions. 1 by z square plus 5z plus 6 can be written as 1 by, this is z square plus 3z plus 2z plus 6, right? So this is 1 by z into z plus 3 plus 2 into z plus 3. You can write this as 1 by z plus 3 into z plus 2, right? So you can write 1 by z square plus 5z plus 6 as 1 by z plus 3 into z plus 2. Yes or no? So you still can write this as, in order to partial fractions, you need to write z plus 3 p by z plus 2. So finally, you need to find a and b values. Take the LCM a z plus 2 plus b z plus 3. They'll write this is equal to 1 because you have a 1 here. So az plus 2a plus bz plus 3b. Write z terms, z common, a plus b. Write coefficient, write constants 2a plus 3b. So you can see you have a 1 here. So finally you'll get a plus b is equal to 0, comparing coefficients. 2a plus 3b is equal to 1. So from this you can write a is equal to minus b. Therefore 2 minus b plus 3b is equal to 1. This will give you b is equal to minus 2b plus 3b. B is equal to 1. If b is equal to 1, what is a is equal to then? A is equal to minus 1. So you can write 1 by z square plus 5z plus 6 is equal to 1 by z plus 3 into z plus 2 is equal to a by z plus 3 plus b by z plus 2. What is a and b values? A is minus 1, b is 1. This is minus 1 by z plus 3 plus 1 by z plus 2. Do you have any doubts till now? So finally you can write y of z by u of z is equal to minus 1 by z plus 3 plus 1 by z plus 2. And you should know how do we draw state diagram to this. You need to draw a, construct the block diagram, or you'll also call it as a state diagram. So construct block diagram or state diagram. To this I'll just tell you one more thing. See, you need to know that if you have 1 by s plus a, in continuous time. S is nothing but 1 by Z plus A. This is discrete time systems. Let's say I'll only first take continuous time and see. If you have this 1 by S plus A, you can represent it with a summing point and an integrator with a feedback of A negative. How and why? If you just try to simplify this, let us call this as G and this as H, and this is a feedback loop if you observe. Now, for a feedback loop, C of S by R of S is equal to G by 1 plus G into H. That is G by 1 plus G into H. What is G? 1 by S by 1 plus 1 by S into A. So what is this you get? 1 by S by S plus, taking LCM in the denominator, you get 1 by S plus A. Final answer. So you can represent 1 by S plus A in this form. Yes, you can. So now let's see. You have what first one? Minus 1 by Z plus 3. This is for continuous. If it is Z here, you need to replace 1 by S by Z, 1 by Z. That only difference. Rest of the things will remain same. So first term, what do you have first term? Minus 1 by Z plus 3. Minus 1 by Z plus 3. Right? So I'll have to represent this. So I'll take a block diagram with first delay as, so you have Z power minus 1. So what is that? You have Z plus 3 right here. So 3. So you need to write here 3 with a negative sign. Right. Now let's go to the next part. 1 by S plus 2, Z plus 2. So you need to take another summing point and write it as this is Z power minus 1, 2 with negative sign. And but in the numerator you have a minus 1 here. So you need to place a minus 1 block here. In the second term you have 1, you need not place anything, you can just directly join, or if you want you can also place 1 and join it with some summing point. Take this as y of z or y of k stating, and join these two with a common input as u of k. Right. Now you need to write after each delay, because if you observe this problem, what is a, this is z square, you got z square, right? So that means this is a two state variable. So we can say x1 of k here. What is the input of z inverse? That x1 of k plus 1. What is here? X2 of k. What do you get here? X2 of k plus 1, right? Now let us write the expressions for x1 of k plus 1 and x2 of k plus 1. We need a matrix like this: x1 of k plus 1, x2 of k plus 1 is equal to a into x1 of k, x2 of k plus b into u of k. What is the size of this? 2 by 1. What is the size of this? 2 by 1, because we know in the given transfer function we got two delays, so this will be 2 by 2. This is 1 by 1, so this is 2 by 1, because we need 2 by 1 here, right? That's the reason. Now, so first let's try to write the equations. What is the equation for x1 of k plus 1? X1 of k plus 1 is equal to, it is the summation of these two plus u of k, that is u of k minus 3 into x1 of k, 3 into x1 of k, right? Next, x2 of k plus 1 is equal to u of k minus 2 into, if you see here, 2 into x2 of k, x2 of k. So let's write those values here. X1 of k plus 1 is equal to u of k minus 3 into x1 of k. Similarly, x2 of k plus 1 is equal to u of k minus 2 into x2 of k. This is x1 of k. Now let's try to write this. In x1 of k, do you have x1? Yes, minus 3. X2, 0. In x2 of k, do you have x1? No, x2, minus 2. Do you have in x1 of k, do you have u? Yes, 1. This is 2 by 1. This is also 1. It's because you have 1 here, you have a 1 here, right? So you'll get a matrix like this. Now you can also write the expression for y. What is y is equal to? It is minus here, it is plus here, right? You can also write minus here or also minus here. What is that? Minus x1 of k plus x2 of k. So just write it down. So in this, y of k is equal to minus x1 of k plus x2 of k. So let's write the y matrix. Y of k is equal to matrix C into x1 of k and x2 of k. Because this is 1 by 1 and this is 2 by 1, it has to be 1 by 2, because unless and until it is 1 by 2, you will not get 1 by 1 resultant. So what is the size of this matrix? 1 by 2. Do you have x1? Yes, minus 1. Do you have x2? Yes, 1. So this two equations, let's call this as first equation, second equation. 1 and 2 is a canonical state model, is a canonical form of state model. Now what is the second one? Second question that is asked, you want to look at this. Let's see. Yeah, the first part is over. Determine the state model in canonical form. You need to do partial fractions method. Second, find the state transition matrix. Find the state transition matrix. For this you need inverse Z transforms. For this you need inverse Z transform. This is reference page, remember. This is not the solution. No. Let's move. Next we need to find state transition matrix. What is state transition matrix? We already know. In continuous time we have seen, in discrete time also same. State transition matrix with a small change. What is state transition matrix? You'll write e power at. Here you'll write z inverse of zi minus a inverse into z. So we already know the matrix A given. A is equal to, given as, I'll write it, minus 3 0 0 2 minus 2. Just now we have got that. So this is x of k plus 1 is equal to A into x of k. So this is A matrix we have got. So from this you need to consider that. So let's write zi minus A first. What is zi? Z0 0 z minus A minus 3 0 0 minus 2. So you can write z minus of minus 3, z plus 3, 0 minus of 0, 0 minus 0 0, z minus of minus 3, z plus 3, right? So this is zi minus A. Now let's try to find zi minus A inverse, that is at z plus 3 0 0 z plus 2 inverse. So what do you get? 1 by AD minus BC. First 1 by z plus 3 into z plus 2 D is z plus 2 minus B minus C A. This is the inverse matrix. Now what is state transition matrix? That is A power k or E power AK, you can write. Right? So you can write state transition matrix A power k is equal to z inverse of zi minus A inverse, that is z inverse of, you can further simplify this, right? You can write z plus 2 by, let's simplify that, then we'll write this state transition matrix. So I'll just try to simplify this matrix first. How do you simplify? You can take this term to inside and you can write z plus 2 by z plus 3 into z plus 2. 0 by something 0, 0 by something 0, z plus 3 by z plus 3 into z plus 2. So can I cancel these two terms here and these two terms here? Finally, what is the matrix that I get? Finally, you get a matrix of 2 by 2 with 1 by z plus 3, 0, 0, 1 by z plus 2. So what is this matrix? So Zi minus A inverse is equal to 1 by Z plus 3, 0, 0, 1 by Z plus 2. Now let's write state transition matrix. What is state transition matrix? What is state transition matrix? A power k. We'll write it as A power k is equal to Z inverse of Zi minus A inverse into Z. So let's try to do that. So first multiply this Z inverse of Zi minus A inverse. Zi minus A Z. Let's write this 1 by Z plus 3 0 0 1 by Z plus 2 into this is the value of Z inverse Zi minus A inverse into Z. So you'll get Z inverse of Z by Z plus 3 0 0 Z by Z plus 2, right? So now what is A power k? You'll write A power k is equal to Z inverse of Z by Z plus 3 0 0 Z by Z plus 2. So you can write individually as Z inverse of Z by Z plus 3 0 0 Z inverse. Even if you apply, let's say Z inverse of, let's say Z inverse of, like Z inverse of Z by Z plus 2. Now what is Z inverse of Z by Z plus 3? It is minus 3 power k. Similarly, Z inverse of Z by Z plus 2, it is minus 2 power k. So therefore you can write, what you can write? Matrix A power k is equal to, what is Z inverse of this term? It is minus 3 power k 0 0 minus 2 power k. So this is the required state transition matrix. So this is the required state transition matrix. State transition matrix. Hope you have understood. Just look at this and we'll also solve the third one. Very easy and very important. So I want you to listen to this and write down your notes as well if you are able to. Yeah, this is the question. And we'll have to also do this third one. See, there is something question given in third part. We'll also do this. For input u of k is equal to 1, k greater than 1, find y of k. So we'll have to find y of k. Just look at this solution. Just look at this partial fractions. First difference equation, from that you get a transfer function. This is the transfer function. If you have understood, please let me know. So the transfer function, in this transfer function, from this you'll apply partial fractions to get the canonical form. So this is the partial fractions. I have done partial fractions also and got a value as -1 and b value as 1. Next, block diagram or state diagram will draw for the this partial fractioned transfer function, so that you get state model that you can write. This is the state model. Next, the second one, state transition matrix. This is the expression a power k. This is the expression a power k is equal to a power k is equal to, this is the expression, right? Z inverse of zi minus a inverse into z. This is same as the continuous si minus a inverse zi minus a inverse into z. Uma Maheshwari, okay. Next, so we have applied z inverse and zi minus a. First we found what is zi minus a, then we found zi minus a inverse, and then we applied inverse zi minus a inverse. Then we applied z inverse. This is zi minus, remember, zi minus a inverse and z inverse of something is different. So first we found zi minus a inverse, that is inverse of the matrix here. Then we applied inverse z transforms to this zi minus a inverse into z. Do not forget to multiply this, if not you will get a wrong answer. Okay, then after this you apply z inverse to each and every term. After multiplying this z to this matrix, you apply z transform. See what is z inverse of z by z plus 3? It is minus 3 power k. Z by z plus 2 minus 2 power k. Now let's see. Now let's write the third one. The third question was, when I'll just write the question once again. The third question I'm writing. This is one 15 marks question, finally full mark question. For input u of k, for input u of k is equal to 1, for k greater than or equal to 1, find the output y of k. Find the output y of k. Now you are given, let's consider the state model first, then we'll try to apply everything. So let's consider the state equation. Let's consider the state equation. The state equation, you know that state equation is x of a plus 1 is equal to a into x of k plus b into u of k. Now let's take z transform to this. What do you get? Z into x of z minus z into x of 0. I told you already, a into x of z plus b into u of z. Now let's assume that the initial conditions are not given and x of 0 is 0 as of now. For now, so what you can write? z into x of z is equal to a into x of z plus b into u of z. You can write z into x of z minus a into x of z is equal to b into u of z. So if it just take x of z common, it is zi minus a is equal to b into u of z. But what is u of z given already? What is u of z? But u is input, right? In question, if you see what is u of z, uk is 1. What is u of z? So u of k is equal to 1. U of z is equal to, that is z transform of u of k is equal to z by z minus 1. Z by z minus 1. Now let's try to do that. Okay, so we already know from zi minus a inverse that, so this is one part. Just remember that this is zi minus a into x of z is equal to p into u of z, right? So from this you can write, x of z is equal to zi minus a inverse into b into u of z, right? Now we already know zi minus a inverse, so you can write x of z is equal to, what is zi minus a inverse? We know 1 by z plus 3, 0 0 1 by z plus 2 into b. What is b? B is given in the question. B is 1 comma 1, not in the question, in sense we got the state model here. Yeah, this one. Yes, yeah, this is b. See, this is a and this is b for the state model. From the state model, this is b. B is 1 comma 1. B is 1 comma 1. U of z. What is u of z? We already know. It is z by z minus 1. Now what is the size of this matrix? 1 by 1. What is the size of this matrix? 2 by 1. What is the size of this matrix? 2 by 2. So the resultant of these two will be 2 by 1. The resultant of these two will be 2 by 1. Right? Just remember that. Now we can just multiply this and finally write. I don't want to just waste time on this. I'll just write directly. So this is z by z minus 1 into z plus 3 and z by z minus 1 into z plus 2. Right? Now we need to actually find, what are we asked to find? Output y of k, not y of z. So what is y of k? That you need to find. For that you need to find, in order to find y of k, you need, y of k is what? Just remember, y of k is equal to, from state model if you see this is y of k is C matrix into x of k, x1 of k, x2 of k. C matrix 1 1 into x1 of k and x2 of k. So in order to get this y of k, we need x1 of k, x2 of k. So this is also, if you observe this, left hand side and right hand side must be equal. So can I write this as x1 of z and x2 of z, right? So what is x of t then? X of k, it is x1 of k and x2 of k, x1 of k and x2 of k. So what is x1 of z? X1 of z is equal to what? Z by z minus 1 into z plus 3. What is x2 of z? It is z by z minus 1 into z plus 2. So you need to find x1 of k for this and x2 of k for this. So for that you need to again apply inverse Laplace inverse Z transform. In order to apply inverse Z transforms, you need to apply again partial fractions. You need to apply partial fractions. So let's try to do that. So let's take first one, x1 of z. What is x1 of z? Z by z minus 1 into z plus 3. Is this correct? Yes, it is. Now, in order to apply, we need to first write this in partial fractions. A by z minus 1 plus b by z plus 3. That is az plus 3a plus bz minus b is equal to z. Now, if you compare coefficients on both sides, compare coefficients. You just take common z here, a plus b into z plus 3a minus b. So, a plus b is equal to left side z coefficient is 1. Right side z coefficient is a plus b. So, a plus b is equal to 1. Next, 3a minus b is equal to 0. So, 3a is equal to b. So, instead of b, you can write 3a. So, a plus 3a is equal to 1. So, a is equal to 1 by 4. Yes, a is 1 by 4. Similarly, if a is 1 by 4, what is the value of b? It is minus 1 by 4. That's what. See, if a is 1 by 4, b must be minus 3 by 4, right? Yeah, it's given wrong here. Because 3a minus b is equal to, is it 3a minus b? Yes, 3a minus b, right? Now, if you substitute this value here, yes, now 3a is equal to b. So, if a is 1 by 4, b is equal to 3 into 1 by 4, that is 3 by 4. Now, let's replace this. So, x1 of z is equal to a. What is a value? 1 by 4 by z minus 1 plus b is 3 by 4 by what is z plus 3. So, can we find x1 of a enough? What is that? Z inverse of 1 by 4 into 1 by z minus 1 plus z inverse of 1 by z plus 3. So, because you cannot apply z transformation 1 by z minus 1, you need to have a z. So, that's the reason instead of doing this partial fractions for, let's see once again, instead of doing this for z, we will just take outside this z and calculate the partial fractions to this, because you need z inverse of z by z minus 1 is minus 1 whole power k. Without z you cannot do it. So what we shall do is we shall just take this z outside, right? Now if you just try to do it this again, just try to do this once again and see. So this is a into z plus 3a plus bz minus b by, need not write that, is equal to 1. Now what is a plus b is equal to a plus b, z coefficient is 0, and 3a plus 3a minus b. Now find out again, 3a minus b is equal to 3a minus b, constant is 1. So a is equal to minus b. So if you substitute 3 into minus b is equal to 1. Minus 4b is equal to 1. B is equal to minus 1 by 4. Therefore, a is equal to 1 by 4. So a is 1 by 4, b is minus 1 by 4. That is correct. So you should not consider this z. Z should be taken out. So then you get x1 of, once again, x1 of z is equal to z into, this is 1 by 4. What is a value? 1 by 4 by z minus 1 plus minus 1 by 4 by minus 1 by 4 by z plus 3. Now you can write this as 1 by 4 if you write outside, z by z minus 1, plus minus 1 by 4 if you write outside, this is z by z plus 3. I'm multiplying this z inside here as well as here. Now you apply inverse z transform, that is z inverse of, what is this value now? X1 of k, that is equal to z inverse of 1 by 4 into z by z minus 1 plus z inverse of minus 1 by 4 into z by z plus 3. Can we do this? I'll write the value. So this is, so finally you can write x1 of k is equal to 1 by 4 into z by z minus 1 is u of k. You can write this is u, and let's say this is 4 actually. So this is 1 by 4, right? Now plus z inverse of minus 1 by 4 into z by z plus 3 minus 3 power k. So this is x1 of k completely. Similarly, I'm just directly writing x2 of k. x2 of k, even you, what you have to do, you have to consider this and take this z outside, and partial fractions you need to apply to this, and then you need to take the z inverse, right? So once you do that, what you get is here x2 of k is equal to, let me do that also for your convenience, because you must have confused with x1 of z. Let's do x2 of z, z minus 1 z plus 2. x2 of z is equal to z by z minus 1 into z plus 2. This, yeah, so let's write z outside and apply a by z minus 1 plus b by z plus 2. Now write it down, z into, just forget about this z for a while and let's do this separately. A by z minus 1 plus b by z plus 2 is equal to az plus 2a plus bz minus b, and here if you observe it is 1 actually, z into 1, so this is equal to 1. So compare coefficients, this is z, this is z, so a plus b is 0. You do not have any z terms to the left side, so a plus b is 0. 2a minus b is equal to 1. 2a minus b is equal to 1. So a is equal to minus b. So 2 into minus b. Substitute this here. 2 into minus b. Minus b is equal to 1. So b is equal to minus 2b minus b minus 3b. So it is minus 1 by 3. What is a then? 1 by 3. So can we write x2 of z is equal to z into, what is a? 1 by 3. 1 by 3 by z minus 1 plus b, what is b? Minus 1 by 3 minus 1 by 3 by z plus 2. So what is x2 of k is equal to inverse z transform of z inverse of x2 of z. Did I write z inverse or z? Yeah, z inverse is equal to, now can you write z inverse of 1 by 3 first term into z by, I'm multiplying this z inside, z by z minus 1 plus minus 1 by 3 into z by z plus 2. What is z inverse of this? Therefore x2 of k is equal to 1 by 3 into q of k, right, minus 1 by 3 into minus 2 power k. Finally x1 of k is equal to 1 by 4 u of k minus 1 by 4 what was that value? Minus 3 power k, and x2 of k is equal to 1 by 3 u of k minus 1 by 3 minus 2 power k. So these are x1 and x1 of k and x2 of k. Now what is that you need to find finally actually? Y of k. What is y of k is equal to? C matrix into, this is C matrix into x1 of k into x2 of k. So y of k is equal to 1 into 1 into, write this x1 of k and x2 of k. What is x1 of k? 1 by 4 u of k minus 3 power k into 1 by 4. 1 by 3 u of k minus 1 by 3 minus 2 power minus k. Is that so? So multiply this. This is 1 by 2. This is 2 by 1. So what is y of k finally? 1 by 1. So just write 1 by 4. 1 by 4 u of k minus 1 by 4 minus 3 power k plus 1 by 3 this into this term plus this into this term. So first part is over. This is the first part. 1 into this total term plus, you need to plus again, plus the second one into this term. So I'm writing that 1 by 3 u of k minus 1 by 3 minus 2 power k. So this is the required final answer. This is the required final answer y of k. Right? So the final answer is this. Yeah, this was asked, the question. Right? So we have solved all these. Let's go back to the main question. The first, yeah, this part. So this is a discrete time system is described by the difference equation y of k plus 1. This is given. Determine a state model in canonical form. So what have we done? I'll just tell you what have we done in this problem. So first thing was we were given a difference equation. First thing was we were given a difference equation. To this we have applied Z transform and obtained transfer function. We have obtained transfer function. What is the transfer function? Y of z by u of z. But we were asked to find state model. So to this transfer function by using partial fractions method, because we are asked about the canonical form. So partial fractions because it is canonical form. So because it is canonical form, we have used partial fractions, and for that partial fraction transfer function we have drawn state diagram. We have drawn state diagram. From that state diagram, let's see, from that state diagram, from this state diagram, by considering the state variables, we have obtained state model. We have obtained state model. That is, what does the state model contain? X of k plus 1 is equal to a into x of k plus b into u of k, and y of k is equal to c into x of k plus d into u of k. This was the first part. We were asked to find the state model, and we have done all these steps, remember. And in the second part, what we have done is we were asked to find state transition matrix. So state transition matrix expression is a power k is equal to zi minus a inverse into z. It's not yet done. Yeah, this is a power k is equal to z inverse of, right? So this is, for that what we have done, first we have written zi minus a, then to that we have taken inverse zi minus a inverse, and after that we have applied inverse, sorry, we have multiplied zi minus a inverse into z. Then to this what you need to do is you need to apply inverse z transforms, inverse z transform, so that what do you get? So that you get stm a power k. This was the second one. This was the second one, right? And third one, just now we have solved. We know y is equal to, from the state model, from the first option, we know 1 and x1 of k and x2 of k. We were asked to find this y of k. This is y of k is equal to, So for that we need to find x1 of k, x2 of k. So to find x1 of k, x2 of k, we need to find x1 of z and x2 of z. We need to find x1 of z and x2 of z. So we have first found x of z. What was x of z? By neglecting initial conditions, x of z is equal to zi minus a inverse into b into u of z. This was what we have found, right? Let me check. Yes, yes. This is what we have done. X of z. This x of z is nothing but x1 of z and x2. Sorry, this x1 of z and x2 of z matrix. You'll get a 2 by 1 matrix here. After you multiply all these, you get b from the state model here. See here you have b here, and you also have u of z. U of z will be given in the question, right? We are given u of you are given u is equal to 1, that is u of k. U of z is equal to z by z minus 1. You need to take this z transform, then you multiply them and first find x1 of z and x2 of z. To that what you do is you'll apply partial fractions. You apply individually, you find x1 of z. From x1 of z you'll find x1 of k, and from x2 of z you find x2 of k. To that what you do? You do partial fractions, right? Then after you get this x1 of k, x2 of k, you multiply it with 1 and 1, you get y of k. So this is the complete procedure that we have followed to solve this particular question that is given, this question. So this is very important question and I want everyone to learn this. Hope everyone have understood this question. Right? So if you have not understood, you can check, go through this once again. Okay. So hope you have understood this. If not, just go through this video once again. Just want to check if somebody is able to respond. Right? This is very interesting and very important session. Hope everyone has understood this session. Right? So thank you so much. As I always tell you, we have this was the control systems complete revision. I'll also post some of the requests from the students from chapter 4 as well on compensated design techniques as early as possible, based on this request from the students. Will also do that. And as I always tell you, we have #1 study channels on Unacademy, and also please do like this video, share this video, and subscribe to Unacademy and Unacademy Semester Exams. You can use my code YSK10 to get the maximum discount on your Unacademy subscription, and you can also click on this bell icon to get more notification of my classes, and you can also join us on Telegram for upcoming videos. So do like and share this video. Don't forget to do that. Like and share this video, and let's crack GATE and ESE with India's largest learning platform, Unacademy. Thank you.